Hello everyone, I welcome you to our YouTube channel. My name is Professor Kevin. So please, if you haven't subscribed, just subscribe to our YouTube channel and also like our videos. You can also share it with your friends or your fellow learners. So on this video, I'll be talking about the exponents. I'll be talking about the exponent. So in order for you to understand or to know this chapter of exponent, you need to master or to know the rules of exponent. So make sure that you understand all those laws of exponent before you attempt the questions. Okay, so on this video I'll be talking about the exponential expression. Then on part number 2 I'll be talking about exponential equation. So now we'll be focusing on the expressions. Okay, so let's say they ask us to simplify the following. Okay, let's take our question. We are given that you have to simplify 6 to the exponent of 6x, then multiplied by 9 to the exponent of 3x, all divided by 54 to the exponent of 4x, multiplied by 1 over 4 to the exponent of 2 minus x. Okay, so we need to simplify this following expression. So the first thing that we need to do here is to make sure that each and every base that you are having here must be written as the product of prime factors. It must be written in the product of prime factors. I believe you know the prime factors or prime numbers. Prime numbers, we are referring to numbers that has only two factors, which is 1 and itself. Okay, so our base here, I'll start with 6. So 6 is not a prime number, so we must rewrite this 6 as a product of prime factors. Okay, the product that we are going to write here is 2 and 3. 2 multiplied by 3 is 6. Okay, and 2 and 3, these are prime factors. So this is what I mean when I say you must write it as the product of prime factors. So it's 2 multiplied by 3, which is to give us this 6. Okay, that is 6 to the exponent of 6x multiplied by. Okay, so when you come to 9, we need to write it as 3 multiplied by 3, which is the same as 3 squared. Okay, if you can check, 3, it's a prime number or a prime factor. So this is how we must express 9, okay, to the exponent of 3x, and then divided by, okay, 54. Yeah, it might be a little bit tricky when it comes to 54, but it's simple. You can simply do this thing. If you want to know the prime factors of 54, you see 2 multiplied by 27, it will still give us this 54. Okay, and then 27 is not a prime number or a prime factor, so we need to expand it also. So the prime factors of 27, it can be 3. Okay, let's expand 27 to be 3 multiplied by 9. Okay, so 9 is also not a prime factor, so to express 9 in the product of prime factors, it will be 3 multiplied by 3. Okay, so now these are the prime factors or the product of prime factors that will give us 54. 2 multiplied by 3 multiplied by 3 multiplied by 3. Okay, it is 2 multiplied by 3 multiplied by 3 multiplied by 3. Okay, we'll come and write it as 2 multiplied by 3. 3, it is multiplying 3 times. Okay, so 3 to the exponent of 3. This is the same as 54. It's a product of prime factors, because if you say 2 multiplied by 3 to the exponent of 3, it will still give you this 54. So that's what I mean when you say we must write everything as the product of prime factors. So 54 to the exponent of, it was exponent of 4x, okay, multiplied by, again we are having 1 over 4. Okay, so when we come to a fraction like this 1 over 4, we must check a 1 over 4. We must focus on our denominator, this one, yeah, of 4. So 4, we can write it as 2 squared. Okay, so this will be the same as 1 over 2 squared. 2 is a prime number or a prime factor, so, and then this one is the same as 2 to the exponent of negative 2. So it means 1 over 4. I'm going to write it as 2 to the exponent of negative 2. This is the same as 1 over 4 to the exponent of 2 minus x. 2 minus x. I hope we are still full. So now we need to apply the rules of exponents. Now we are going to apply the rules of exponent. The first thing here was to write every base as the product of prime factors, but now we are going to apply the rules of exponent. That's why I said we must master those rules of exponent. Okay, so this one is going to give us 2 to the exponent of 6x times 3 to the exponent of 6x multiplied by 3 to the exponent of 6x. Okay, so these are the roots of exponent. If you're having a multiplied by b all to the exponent of m, okay, so this is what we need to do. You check the exponent of every variable here. Okay, so the first variable here is a, so the exponent of a is 1, so you're going to say this one multiplied by this exponent of m, so it will give you a to the exponent of m, because 1 multiplied by m, it will still give us m. Okay, multiply by b. When we come to b, we also check the exponent of b. The exponent of b is 1, so we're going to say 1 multiplied by m, which will still give us m. So this is how we apply these rules of exponent. And again, we also have this one. If you're having a to the exponent of m, and then here having exponent of n. So what's going to happen here is that you are going to multiply this exponent. So you're going to say a to the exponent of m multiplied by n, which is going to be mn. Okay, so you need to know all these rules so that you can be able to answer or understand this kind of questions. So here the exponent of 2 is 1, so 1 multiplied by 6x is going to be 6x. Even here the exponent of 3 is 1, so 1 multiplied by 6x is still going to give us 6x. Okay, so here we said 2 multiplied by 3x, then we get 6x. That's why we're having 3 to the exponent of 6x. I hope you are still following. And then now let's focus on our denominator. We're going to have 2 to the exponent of 4x multiplied by 3 to the exponent of 12x. 3 to the exponent of 12x, because 3 multiplied by 4x, I said we're going to multiply the exponent. 3 multiplied by 4x is going to give us 12x. Okay, multiply by 2, negative 2 multiplied by 2 is going to give us negative 4, and then negative 2 times negative x is going to give us positive 2x. Okay, positive 2x. So that those were the rules of exponent. Those were the rules of exponent that you need to know before attempting this kind of questions. So now we're going to apply again the rules of exponent. We know that when we are multiplying something that has the same base, we are going to add the exponent, and also when we are dividing something that has the same base, we are going to subtract the exponent. So here our base, if you can check, is 2 and 3. It's 2 and 3 only. So I'm going to say, okay, let me copy that base of 2. We're having 2 to the exponent of 6x. It is dividing with this one, 2 to the exponent of 4x. So I'm going to subtract 8 minus 4x. Then again, this one of 2 to the exponent of negative 4 plus 2x, it's also dividing. So I'm going to subtract that exponent. Minus 2 minus 4 plus 2x. Okay, multiply by 3. Because another base is 3. So we're having 3 to the exponent of 6x multiplied by 3 to the exponent of 6x. So we're going to add the exponent there. Okay, again we are dividing by 3 to the exponent of 12x, so I'm going to subtract the exponent minus 12x. So let's find out what will be our answer. So let's simplify these things. 6x, or let me start by writing the base 2. Okay, 6x minus 4x, we're going to get 2x. Then 2x, this one is going to be minus 2x. So 2x minus 2x, we're going to get 0. Then negative times negative, negative times negative is positive. Then we'll be having positive 4 as our exponent there. Okay, those are the method of simplifying. Again, here 6x plus 6x is going to give us 12x. Minus 12x is going to be 0. So we'll be having 3 to the exponent of 0. So 2 to the exponent of 4 is going to give us 16. Then 3 to the exponent of 0 is going to give us 1. So 16 multiplied by 1, our final answer is going to be 16. So that's our final answer. I hope you have understood this question. So let's go to the second one. Okay, so here's our question. It's also the expression. We have to simplify this. We are given 2 to the exponent of 2x plus 2 plus 2 to the exponent of 2x minus 1. Again, in the denominator, we're having 4 to the exponent of x plus 8 multiplied by 2 to the exponent of 2x minus 4. Okay, let me change this one and make it minus. It will be minus, right? So the first thing here is to check that every base that has the exponent in terms of x, né? We have to check that every base that is containing the exponent of that is in terms of x, we must make sure that it's a prime factor. If it's not a prime number or a prime factor, we must write it as a product of prime number. We write it as a product of prime factors, okay? So here we're having 2 to the exponent of 2x plus 2. So 2, we know that it's a prime number, so there's no need for us to write this thing as a product of prime number. Okay, so it's okay. So it will be 2 to the exponent of 2x plus 2 minus, again here we're having 2 to the exponent of 2x minus 1. That one is okay. So when you come to the denominator, we're having 4 to the exponent of x. Okay, so 4, it's not a prime number, so we need to write 4 as a product of prime factors. Okay, this will be 2 to the exponent of 2 all to the exponent of x plus. Okay, so when you come to 8, you don't have to worry about 8 because 8 is not containing the exponent that is in terms of x. 8 is not containing the exponent that is in terms of x, so we don't have to worry about it. Yeah, we only focus on the basis that has the exponent in terms of x. So 8 is fine, you just leave it the way it is. So 2 to the exponent of 2x minus 4. Okay, yeah, we only focus on the basis that is containing the exponent in terms of x. So now again, when we are simplifying, if you are simplifying the expression that has addition or subtraction, if you are simplifying like exponential expression that has addition or subtraction, okay, you need to split this exponential. Okay, so I will start with this one. We need to split it. It will be 2 to the exponent of 2x multiplied by 2 to the exponent of 2. Okay, I just split this one. Again, minus 2 to the exponent of 2x multiplied by 2 to the exponent of negative 1. We only split when we are simplifying the exponential expression where we'll be adding or subtracting. Okay, if it's all about the multiplication like the previous example we're doing, no need to split it. There is no need for us to split. But if you are simplifying the exponential expression that has plus or minus addition or subtraction, you need to split here. So again here, if you simplify this thing, is going to give us 2 to the exponent of 2x. All right, it's going to give us 2 to the exponent of 3x plus 8 multiplied by, let me spell it, this one is going to be 2 to the exponent of 2x multiplied by 2 to the exponent of negative 4. Right, I hope you are still following. So now, if you can check on our numerator, we have a common factor. We have a common factor of 2 to the exponent of 2x. So we need to take out that common factor, 2 to the exponent of 3x. We will be left with 2 squared minus 2 to the exponent of negative 1 divided by, okay, on our denominator still the common factor is the same as 2 to the exponent of 2x. Okay, so here we are going to be left with 1. Okay, many people usually make this kind of mistake. If they factorize, they don't write 1, they only write 0, and it's wrong. Yeah? So we'll be left with 1, not 0. Then plus, so in here we'll be having 8 multiplied by 2 to the exponent of negative 4. Right? So this one and this one will divide each other. So on our denominator, we will be having 2 squared is going to give us 4 minus 4 minus 4 minus 1 over 2, because 2 to the exponent of negative 1 is going to give us 1 over 2. Okay, again we'll be having 1 plus 8 multiplied by, okay, 2 to the exponent of negative 4. We're going to get 1 over 16. Okay, going to get 1 over 16. So let's simplify this thing. 4 minus 1 over 2. 4 minus 1 over 2, I believe that we're going to get 7 over 2 divided by, so here on our numerator again, just press everything with your calculator to make it short. So it will be 1 plus 8 multiplied by 1 over 16. Okay, I believe that we're going to get 3 over 2. 3 over 2. So you can simply take this 2 divided by 2, and then you will be left with 7 over 3. 7 over 3 will be your final answer. Or you can write it like this. If you don't understand that method of dividing 2 and 2, you can say 7 over 2 divided by 3 over 2. Okay, so this will change to 7 over 2 multiplied by 2 over 3. Then these 2 and 2 will divide each other, so we'll be left with 7 multiplied by 1, which is 7. Again, 1 multiplied by 3, which is 3. So the final answer is 7 over 3. Okay, so that's all for today. I believe that you have enjoyed this video, so please don't forget to like our videos and also subscribe to our YouTube channel. Thank you.